Hey,
Hey.
we are live, Michael. So
Hello.
I would like to welcome everybody to the Committed to Quality interview series. Today we have Michael Bolton on board. So please join Slider. You can see the QR code below. You will be able to ask questions in the Slider. But let's start for the greetings. If you would like to say hi, Michael, or hello, Michael, nice to meet you. So please do this. So Michael will be able to see you.
Oh, are you sure you want to do that? There's a lot of people on there.
Yes, yes.
We're going to lose some questions if we do that. All right, I'll take that question then.
Don't forget to join Slido if you would like to ask a questions. But please note, we are not, please don't ask questions now, just say hello because we will have a separate session at the end of the translation to ask questions for the Michael. Okay, let's start. Here it's Victor, Anthony, Olga, and Michael Bolton. Michael, hey,
Hey,
Hello. How are you?
good, and you?
Good. Staying safe, keeping well, are you?
Yes, thank you. Let's start from the simple question. How long you in profession?
Which profession?
Software tester.
Software tester. Well, I guess I've been a software tester as an amateur since I first got my first computer, which would have been 1981 or so. But uh, as somebody who tested software, I started becoming a tester when I started becoming a programmer in 1987 or so. That's when I was getting money for programming. And then I've got my first uh, job with the title tester. I mean, I was a tester when I was a technical support person too, from 1990 to 1994. But I got my first job with the title tester I was seconded to the testing department at Quarterdeck in 1994, January of 1994. So I started work on the 4th of January 1994 as a tester. And I've been a program manager, I've been a developer, I've been a documenter, I've been a program manager. In each one of those roles, I'm a software tester.
Okay.
Happy.
so almost 30 years, and are you not bored with the software
Of course
testing?
not. How could you
But
get bored doing testing? People are paying you money in order to learn things. Lots of people go to university for years and years, and they have to pay to do that. But I get paid to learn stuff. That's my job. I get to learn stuff on behalf of other people. And of course, as a byproduct of that, I get to learn stuff for myself. And in order to keep my skills sharp, I have to learn stuff for myself too. It's a great job in that respect. I'm not bored. No, if you're bored, it's like when you're bored in your relationship. It's a sign that there's something wrong.
so
You better do
it's
something.
all about money, not about inspiration.
No, no. On the contrary, I'm excited to be. I'm just lucky to be paid for it. I'm excited to do the work. But it's not boring because I'm learning stuff every day, all the time. And as I say, if you're bored, if you're not learning stuff every day, there's something about your testing that's wrong. There's got to be something about it that's wrong. You are we're our job is to learn things,
So that's
and
why.
to me, learning is fundamentally exciting.
So this is the only reason you prefer testing over development and tech support, right? Because you've doing all those things before, but you stopped exactly it's software testing. Why?
Well, I'm still not a 100% completely committed full-time tester, in the sense that a large part of my job these days is teaching people how to test, helping people how to test, and consulting on how to test. And so that is a whole different set of things to learn about. But why did I stop being a developer? Well, I still develop code. I'm still writing stuff. The other day, I had a fun little exercise given to me by James. I can't tell you about it because otherwise it would telegraph the exercise for people who might be taking it in a class that we're teaching eventually. But the exercise was to use tools, to use automation, to try to figure out the probability of something, and to try to figure out the ranges of probabilities and the variations in the way things turn out. Well, I'm writing code to do that all the time. It's just that for me, when I was a developer, writing something new didn't excite me very much. I really love being a maintenance programmer. I really love going into code and finding pinpointing a bug, right? Finding where a bug was and fixing it and making things a little better. But I am of the, as you've already noted in our conversations before the formal interview started, I'm of the critic mentality. My job is to complain about things productively, right? Because I think if we want things to get better, we have to acknowledge how they're not so good. And we have to focus on finding out how they're not so good instead of just allowing our victims, our customers, to discover it by accident. Right? I think it's a really important job to look deliberately for problems in things. And I'm just of that nature. Some people say the glass is, it's a George Carlin joke. Some people say the glass is half full. Some people say the glass is half empty. And my job is to say, well, what if the glass is too big? Right? So... but if I decided to be a programmer, I'd be a great programmer by now. It focused on it, but it didn't interest me so much. But I would have been determined enough as a programmer to get excellent at my craft. It's just that wasn't the a star I chose to follow, really.
Just a quick additional question. You mentioned the mindset. Do you think that the main difference between developers and testers are just in mindset, but not in skills?
No, I don't think that's true. There is a difference in the mindset for sure, but that plays out as different tasks to perform, different things to focus on. Even between two developers, the skills aren't the same, and that's good. That's a positive thing, because two developers working in collaboration with each other can, I think, do better work than one working on his or her own. While we're at it, I was having a conversation on my front porch last night. We had a couple of friends over, and it is increasingly becoming clear to me that we were making a fundamental mistake about the nature of humanity. We believe that the nature of humanity is the individual, right? The person. And there's something to be said for that. But as I study more and more about testing and about sociology and about anthropology, I'm becoming much more interested in the idea of the function or the basic unit of humanity as being groups of people, social groups, people who are working together. The thing that makes us different from most other animals who are walking across the face of the earth is that we've developed very elaborate social systems for getting things done. And that's how we've been able to do so much as human beings. We've been able to talk to each other, express things very specifically and very precisely to each other, but also to talk to each other in ways that convey not just the facts or the details of a thing, but our feelings about them in ways that are very deeply expressive. And that's something really, really important, I think, when we consider that a builder's mindset on its own is great, makes wonderful things. But when you put that person, him or her, in collaboration with another builder, then what they create is likely to be more than what either one of them could have done on their own. And when you put a developer in partnership with a tester, then you've got somebody who's focused on envisioning success, and you've got somebody else who's focused on anticipating failure. And when you put those things together, that's super powerful, because the builder is building stuff, but doesn't necessarily see the problems in what he or she is building. So as a tester, that's my job. That's my role. When the tester observes a problem, then the builder has the insight and the opportunity to see how his or her solution could be better.
So this is interesting. Like during this answer, you're just talking about like the soft skills, right? More than technical skills. And usually this question is always challenging for people. Like, see, like 10 years ago, 15 years ago, there was much higher barrier or requirements for the developer, tester, whoever, because the technology was pretty complex. But in these days, the technologies gets more and more easier to use, and you need less technical skills to use the technologies. So seems like in future, you would need just a minimum amount of technical skills, but a large set of soft skills, communication skills, negotiative, blah, blah, blah. So just would like to ask your opinion. What do you think about this?
I don't think that's strictly speaking true. For instance, what's the easiest way to put this? Anything that looks simple to us, sitting where we are, has enormous amounts of hidden complexity to it. For example, what have I got here? I've got a coffee mug. Okay? Simple thing, right? You know how to make one? Me neither.
I can only guess.
Yeah, you can only guess. Well, it appears to be simple, right? But look at this. There's these little edges on the side here, and there's a dimple in the bottom, and there's a handle and stuff like that. Now, in grade 8, which means I would have been about 14 years old, we made some stuff out of clay, and there was an oven, there was a kiln, and you could fire it, and it would come out. And of course, mine looked terrible because I didn't have the skills that I needed to do that. But when we say that things are getting simpler, what we're observing is things that used to be hard are simpler now, right? It used to be quite difficult for somebody to put some text on a screen, let's say. Eventually along came programming languages and compilers. Long before that, there was also this hardware that got developed in order to take some signals from a processor and convert that into a signal that could be used by a television interface adapter, and then would put that signal up on the screen, and all of a sudden you get the letters "Hello World" there. That was easy, but it was only text-based, of course, right? Now we have tools that will allow us to put up "Hello World" in any font we like and in any size we like. So that's easy now. That's way easier than it used to be. But as things get easier to do, human ambition rises, right? Our capacity to do stuff as our grasp extends, we just reach further, right? So all those things that appear to be easy now, those are going to that ease is hiding an enormous amount of complexity and sophistication and engineering. And so now it's really easy to do that. Yeah, I wanted to build something, a piece of electronics, say for example, used to be I had to figure out how to create a circuit using a capacitor and a diode, I think, in order to make a timer. Well, back in the 1960s, I think it was, out came the 555 timer, this little black box, literally a black box, where when you send a signal to it and adjust the a signal just so, it sends out a pulse at a certain time. So that got taken care of, and that's easy. Well, now there's I don't know how many thousands, maybe even millions of timers there are like that on a microprocessor, right? On the Intel or ARM chips. But all that means is not that we sort of sit back and put our feet up. All that means is we're going to do more and more complex and more interesting stuff, I hope. So human ambition will take care of the, everything's simple now problem. Don't worry about it. Things will get complicated again as soon as somebody says, here's something else I'd like to do. Yeah.
Michael, you said that you criticize a lot, maybe, because it's part of your job to tell what is wrong to the developer, to the builder. But what about your personal life? Do you criticize? Do you have this mindset in your not professional life?
Oh, sure. And that means I have to be careful at home.
Yes, actually, that's what I'm asking.
Yeah. Look, having that natural bent, that natural tendency to notice problems in things, it comes from a good place, right? I want to be helpful, but sometimes it doesn't come off as helpful, and that is something that we have to manage. James Bach puts it very nicely. Try not to be a tester at home.
Yes.
So are you succeed in trying not to be tester at home?
Oh, not always. Not always. None of us are perfect at everything, and I'm certainly not perfect at restraining the capacity to point out the problems. Sometimes I just have to say, "Wow, that well done," and leave it at that. It's an awkward job to be a tester, right? It's socially awkward. Our job is to find problems. And I fundamentally believe that. People keep saying, "Oh, I want to prevent problems." Well, you know what? Go ahead, prevent all the problems you like. But how will you know that you've prevented problems until you go out looking for them? How will you know? I guess the customers, Yeah.
Michael, you are talking a lot about the humans, about the future of humans, and about the complexity of the technology. I think I should ask you not a simple but probably not too hard question. Do you believe in creator of universe? Do you believe in God?
I don't. I'm an agnostic. I don't know. And as a scientist, I have to say I don't know, right? To the degree that I'm a scientist at all, I have to say I don't know. I was brought up, by the way, as the son of an Anglican priest. My father was a priest.
Oh.
And my mother is still very much involved in the church. I find it most helpful to think of God in terms of a metaphor, a way in which we can explain something or describe something that we would like to believe in a way that sort of fits for people to wrap their minds around. Do I believe in a man, and it's almost always a man in the West, who sits up in the sky and looks down on everything that we're doing and so on? No, I don't believe in that. But do I believe in the kind of principles that religions tout at their best, which is basically be nice to everybody, be fair, or as George Carlin, the comedian, put it, love your God, love your neighbor, love yourself, because basically they're all the same thing, right? If we are, as I was saying earlier, if humanity is a group, a collective, and not just a collection of individuals, then that, it seems to me, makes perfect sense that God, yourself, your neighbor, they're all part of the same whole. So I'm an agnostic. I don't know if somebody pushed a button for the Big Bang to happen or if it just happened.
Okay.
But in a way, it kind of doesn't matter. It doesn't matter because we as humans, what's another George Carlin line is, we invented God in our own image and likeness, right? And so, God is whatever we want God to be, isn't it?
Okay. Thank you for the honest answer.
I got a question. Probably most of us, or probably everybody, have this question for our own self. But so usually, like you're doing lots of teaching, mentoring, coaching, consulting. You're going to some conferences. You learn things a lot. But how do you support your life-work balance? Like because many people can't do that. For example, I usually I can't rest at the classic sense of this because I'm just always thinking about like some work things or some work-related things. How do you handle this?
Well, there's a couple of ways. One is I tried not to think of my work too narrowly. Some people get interested in politics, for example, right? But testing is enormously political because the decisions about quality are always political. They're based on whose values matter, who's running things, who gets to make decisions, which customers matter a lot, which customers don't matter so much. So any kind of interest I have in politics can fold back into testing. But my principal way of getting outside myself is there.
Well, you can play the guitar.
I can play the guitar. I actually prefer more of the time these days to play banjo and mandolin. I play Irish traditional music for fun. And what's interesting about that is when I'm immersed in it, all that other stuff disappears, right? I mean, it just, I go into a kind of zone where all that's happening is the music. Now, of course, there's still a little bit of testerliness in there because I'm constantly deciding whether I'm happy with what I'm playing and how I'm playing or not. And there's a funny thing about that too, which is as soon as you start thinking like that, it interrupts the playing. Or I find as soon as sometimes I do something that impresses me and I think, wow, that's really good. And of course I immediately make an obvious, stupid rookie mistake because I'm thinking about what I'm doing rather than just letting it happen, rather than doing it. So that's a really interesting reflection on testing as well, because part of what we do involves deliberate practice, right? Focused, okay, I'm going to try to get better at this one thing. And then a lot of what we do involves this wonderful spontaneous mode wherein we're doing stuff and we don't even quite notice ourselves doing it. And that's a wonderful space to be in. So music is one way get out of I get out of that. Now, I also love riding my bike. But even then, when I'm riding my bike, a lot of the time I've got a podcast on about something or other that's interesting. But to get the work-life balance, it seems to me one of the better ways to do it is to just be an explorer of the world, as I think as Carrie Brown put it. Just let the world come to you, and then when you're interested in something, go after the world and go have a look for stuff. And at that point, it's not a question of either or. It's a more integrated thing where the work and life just fit really, really nicely together.
Okay, pretty interesting. I forgot to ask you, I would say, more philosophy question. How the industry changed over the time? You are so
That's
long.
a philosophical question.
How industry changed over time? You
Which industry are you talking about?
software testing.
Of testing?
Yes.
Not enough. Not enough. We're still doing things that were dumb ideas in the 90s, and they're even dumber now. Look, one thing that we haven't figured out, that the testing community by and large has not figured out, is that testing is not governed by the desire or the attempt to show that the product works. It should not be. I mean, I'll get back to a nuance of that in a second. But the idea that any agent, either a person or a machine, should be going through a formally scripted procedure that says, do this, do this, do this, do this, do this, and then check to see what the output is. And then if the output is equal to what we anticipated and desired and predicted, pass. And if it isn't, fail. Well, that is there's an element of testing to that, but that's the least interesting and least important thing about testing. It seems to me. Now there's a nuance which I want to put on, and that is that as you're building the product, as you're putting the pieces together, it is a really good idea to do that. As you're building each individual little piece of the product and putting each piece together with some other piece, it's a good idea to do that, it seems. Not necessarily too procedural, but enough to say, okay, does this and this, do these two things fit together reasonably well? Or when I write these few lines of code, are they reasonably close to what I intended them to be? Okay, that is a frame for testing, a kind of a space in which testing can happen that James Bach and I have come to call the discipline frame. Okay, as we're building something, we want to be aware of what we're building, and we want it to be reasonably close to what we think we're building. And that's important. I don't want to dismiss it. But we've got a kind of vitamin deficiency in the testing business, where we're not paying attention to another really, really important kind of testing. And the reason, there are various reasons for that, which I can get to in a minute, I guess. But it seems to me that after we've put together a bunch of parts that are working just fine, it's super, super important to ask ourselves, are there any problems that might have eluded us so far? Are there any problems that might have got past us? Especially when we've got a bunch of things that work just fine on their own and work just fine together, except when some assumption or some notion that we have about the way the world works or the way the world should work changes. Now, it seems to me that a really good way of thinking about this comes from There's an example in a book by a woman called Nancy Levison, and the book is called Engineering a Safer World. And she describes a system, and the details are not terribly important, but I'll try to get as detailed as I can without taking too much time. But the system is a big vat in which chemicals are being mixed in order to produce some desirable thing. And so there are ingredients in the vat, and then there's a catalyst which gets dumped into the vat, which accelerates the reaction, right? Which enables the reaction, makes the chemical reaction happen. And then there's also water to cool the system down. If too much catalyst is in there, you put in some water, and that slows everything down, and the reaction doesn't happen quite so fast. And then there's a vent at the top where if the pressure inside this system gets too high, it opens up. Now, unfortunately, when it opens up, poison gas escapes. But that's better than the system blowing up, right? You don't want the vat to blow up. Much better to reduce the pressure and so on and so forth. And then there's also another system that alerts the human operators when there's a problem, so the operators can adjust the amount of water or the amount of catalyst. So you've got this idea of a system that's, pretty well controlled, and there's human supervision over it and all that, and everything's great. All right. So when they put it in operation, a reaction started to get too hot. Now, part of the design of the system is whatever the state of the system, don't change it until a human operator has looked at what the situation is and has has evaluated it in his or her head and made a change, right? So just keep the system as it is. Well, of course, if the system is getting increasing amounts of catalyst and the reaction is getting hotter, and then the system says, whoa, things are getting, the sensors in the system say, whoa, things are getting hot, notify the human operator. Well, what happens is not slow everything down to a safe level. It's keep things as they are. And then the human operator has to be notified and has to make sense of the situation and change things. But of course, that turns out to be really bad because it takes a bit of time for the human to evaluate it. It takes a bit of time for the human to decide what to do. Meanwhile, catalyst is still coming in. The reaction is getting hotter and hotter and hotter. And so the valve at the top of the system lifts and out goes the poison gas. And now that's escaped into the environment and people are harmed by that. And yet, the way I described the system at first, before I got to that part of the story, I bet you were thinking, that sounds reasonable. And we always think that. Right? We tend to put stuff together and we tend not to think about, okay, how could this go wrong? And we learn about that through experience. And so this other kind of testing, which we are coming to call experiential testing, which I think people are misnaming as manual testing. It's not about, the input device is not important. Is not the important part of this. You can do experiential testing. You can get experiential testing with a product using tools in all kinds of ways to help you gain experience with it. But a lot of the experience that people have of the product is going to be interactive. It is going to be hands on keyboard and mouse in hand and eyes on screens and that. I think our excitement and an enthusiasm for automation is causing us to binge on it, right? We're eating too much automation and we're getting sort of automation bloated. We're not thinking in terms of, well, how do people actually experience this product? How do people interact with it? And in getting that kind of testing, which we call deep testing, which is focused on maximizing the probability of finding every elusive bug that matters, focusing on finding every bug that might have got past us. We're deficient in that, it seems to me. And there's some reasonable reasons how we got that way. It started reasonable at first. Deep testing takes time. It takes effort. It takes skill. It takes support from the team. It takes support from management. It takes patience. It takes determination and commitment, because we won't stumble into deep testing by accident. We have to want to do it. Now, the problem that we've got is that businesses are saying, we got to release, which is, that's all right. It's okay for a business to want to release. The question we have to put on the table is, do we want to release with the risk of important bugs that we don't know about because we don't have sufficient experience with the product, because we haven't tested it deeply? The assumption is that if we have a bunch of components that are well checked, and if we have a whole bunch of automated checks that we run really quickly and do shallow testing, then that'll be fine. Now, there's another thing I want to say about this, which is that when I say shallow testing, that sounds kind of like an insult. It's not. It's not. Shallow testing is important for several reasons. One is it doesn't slow down development very much, right? It allows development to go nice and quickly. When we're only doing shallow testing of something, we're not interrupting the development process too badly, right? We get a chance to learn something about the product. We're trying to maximize there the chance of finding every easy bug. That's what we're trying to do. We're focusing on trying to find easy bugs. And that's good. That's a good thing. Another reason that shallow testing is important is shallow testing is a step towards deep testing. When I test a product, when I'm encountering a product or a feature or a user story or some aspect of some product for the first time, I start by testing it in a shallow way. I have to, because I can't develop a deep appreciation of something without going through shallow first. It's like, going to the beach. If you're standing on the shore of the water, you can't get to the deep water without going through the shallow water. So shallow testing is important. Shallow testing is necessary. Shallow testing is a good thing. But there's two things that I'd like to see us do. One is to make shallow testing deeper. Just automatically make it a little bit deeper. And we do that by inducing variation and by broadening the ideas that we have as we're doing shallow testing. Another thing I'd like to do, though, is I'd like to make deep testing cheaper. So make shallow deeper and make it cheaper. Right? But there's an idea that automated, good. Not automated, not good. But how much of testing can be automated? How much of testing can be automated? Well,
that's a good question.
How much of testing can be automated? Well, let's ask this question. What is testing anyway? If we know what testing is, then we can figure out how much of it can be automated. So here's what testing is, in our point of view. In rapid software testing, this is what we say testing is. Testing is evaluating a product by learning about it through experiencing, exploring, and experimenting, which includes, to some degree, studying the product, modeling it, manipulating it, observing it. It involves generating ideas about how to test and generating ideas about what the product might be. It includes expanding on ideas that we've generated. It includes refining ideas that we've expanded on. It includes overproducing ideas. It includes abandoning ideas that we've overproduced, and it includes recovering ideas that we've abandoned. It includes recording and reporting what we've done. It includes navigating and map making through the product. It includes critical thinking. It includes risk analysis. It includes collaboration with other people. It includes the building, the creation of tools. It includes the application of tools that either we've created or that somebody else has created. Okay, now those things that I mentioned, things within them can be automated, maybe. But on the whole, almost none of them can be automated. Can you automate learning? people talk about machine learning. Shut up. It's a metaphor. The machines aren't learning anything, right? Machines aren't learning anything. They're refining an algorithm. They're not actually learning in a way that it reflects in any way what human learning is like. Can machines study something? No. Can machines think critically? Obviously not. Can machines perform risk analysis? Obviously not. But human beings can use machines to help us with those tools, or with those tasks, rather. We can use tools to help us with those tasks. We can use machines to help us visualize patterns in the data. We can use machines to help us generate data that we can use for testing. We can use machines to help us go through huge volumes of data and refine our observation to the very thing that we're interested in. And we can also use machines to blind us, because machines are agnostic about the effect that they have on us. If a machine helps us to focus on something, it is helping us to defocus on everything else. It might be really important to focus on that thing, so that's a good thing. And it might be a terrible mistake not to see the other stuff, or it might be okay. The machines don't make that determination, though. We do.
So we shouldn't trust the machines, right?
We shouldn't trust the machines any more than we trust ourselves.
Oh, that's correct.
Because the machines don't do anything other than to extend, enhance, accelerate, intensify, enable human capabilities. No machine ever said, this test is a stupid idea. No machine ever says, there's no risk here. Why am I bothering to do this? Machines don't say, I wonder what would happen if. No machine has ever said, how would a user be upset by something to do with this feature? No machine has ever said, hey, you know what? There's a feature missing here. You really should have this thing where you have a second factor for authentication here. No machine ever does that. Now, we could program a machine to say, oh, and by the way, have you remembered 2FA in your security strategy? We could do that. But that would just be, it seems to me, an enactment of some other human's idea, maybe even our own idea, of a reminder of things that might be important, a checklist. So we have compiler checkers that go through code and say, okay, so here's some obvious things that could go wrong. But no compiler checker will ever tell you, will the user like it? That requires a complex human social judgment. We need people to make that evaluation.
I think, Michael, we are moving to the discussion about rapid software testing approach. So we have created a pool. So we would like our audience to open the Slido on the mobile and participate in the pool. Actually, we are going to ask basic things about which approach you are using in your everyday work in the field of software testing. You are using some kind of fun and interesting approach explained by Michael, or you are using more classical approach, I would say ISTQB-like or things like that. So please go to the slider and vote.
If you are choosing option 3, I use both, depends on context. Put yourself back up in number 1. Number 3 is not a valid.
Yes,
True.
Yes, my fault.
Come on. I use my own approach. I use my own approach. It seems to me that is also number 1. I don't know. I just test. I feel sorry for those people. I guess. But but that could be okay. Right? I mean, I think it's important for people to recognize that when you say, I don't know, I just test, what you really mean, it seems to me, is I'm not sure how to describe what I do. But one of the things that we do in rapid software testing is we try to help people understand what they do and to make choices about it. Right, to make it clearer.
Finally, we have I don't test at all.
Yes.
Yes, finally. I expected.
I was waiting for that.
Yes,
And
yes.
what's your answer on this question, Michael?
Maybe some developer can come.
Yeah.
I just test.
Sorry, I don't test at all.
I just
No,
test.
no, no,
Because
no,
you
no,
teach,
I'm-
right? Yeah.
no, no. I'm sorry. I didn't understand the question. You're asking what I do?
I mean,
I-
what is your response on this question? What will be your response?
My response would be I aspire to context-driven
Oh, wow.
approaches. I want to do that.
Don't you use your own approach?
Oh, yeah,
Of
that's
course.
what
Part of my, but that's why I think questions 3 and 4 are really all the same. Because you make, see, the thing is, I try to make choices when I test, right? I try to choose the test that I think is most important for me to do right here, right now, based on a whole bunch of context factors. Now, I noticed one of the early questions was, how do you decide what that is? Well, here's some things I think about when I'm considering the context, okay? I think in terms of what is my mission? That's the overwhelming question. What is it that my client wants to know? What is it my client needs to know? And as a part of that, what do I need to know? Right? Now, when I talk about my client, I've got to also be careful to note that there are numerous clients involved here. The clients of testing include my primary client, the person I'm answering to, the person I'm reporting to. But it also includes the developers. It includes other testers. It includes the documentation people. It includes the overall business, the development manager and the test manager. It includes the sales and marketing people. I'm testing on their behalf as well. I'm testing in the interests of the business. But also, of course, I'm thinking in terms of what the customers might want. And I'm also trying to think of forgotten customers. I'm trying to think about ones who are just not this vague, sort of normal, everyday, oversimplified model. I'm trying to get a rich set of ideas in my head about who might be using this product and who might be forgotten, who has some kind of particular, who might have a problem that we haven't thought about or that we haven't considered. So I'm thinking about that. I'm thinking in terms of the information that's available to me and the information that I need to discover, I need to find out. I need to think in terms of, when I'm figuring out the context, who are the developers? Where are they? How many are they? Do I know them well? Am I in close communication with them, close collaboration with them? Which developers really matter, which developers can be helpful, which developers maybe not so much. I have to think about my test team. What skills do we have? What skills do we need? How do I interact with them? How do I get along with them? Who's really good at doing what? Who needs help? Who should we keep away from this particular part of the product for now? Who can help me to become more powerful as a tester? Who can I help? I'm thinking about the equipment and tools that I have available to me. What do I have? What do I need? How's my test lab set up? What are my testing environments? Have I got the breadth of stuff that I need in order to do a good job of testing this application? What's the schedule? What's the pulse rate of the project? When are the builds coming out? Well, if we're getting 40 builds a day, one thing I'm going to be telling my client right away is I'm not going to test 40 builds a day. I'm just not going to do it. I can't. Unless you want me to do incredibly shallow testing for every build. If your business is doing 40 builds a day, let's do the math. That's in an 8-hour day. That's going to be help me out now, 5. So one every 12 minutes. So am I going to do deep testing on am I even going to be able to install the product again every 12 minutes? Right? Is it going to be available to me such that I can be set up and ready to perform a test? Well, probably not. So what I'll do is I will focus on a particular build right now, and I will suggest that it might be a really good idea for programmers to check their work to prevent really bad surprises in the next 50 or 250 builds they do, and then I'll I'll work on another build and I'll work on that deeply. So that's a schedule thing. Are there any important milestones or deadlines coming up? Does a company have a big trade show coming? I noticed the Roman Podolyan in LinkedIn was talking about that the other day. Where he saw a big bug in the product, and the business said, no, that's okay. We'll just stay away from that area of the product during the big demo for the client. We're not going to fix that one right now. So that schedule thing is there. What is this thing I'm testing? That is a huge element of the context, right? Because the kind of testing I do for a bank is very different from the kind of testing I'm going to do for an online gaming service. And that's going to be very different from the kind of testing I do for an online dating service. And that's going to be very different from the kind of testing that I do for infrastructure for a web host someplace, right? All those kinds of testing are they got to be context driven. And then, what does my client want me to deliver? That's another question I'm thinking about in terms of the context. Bug reports, probably, for sure, but probably test reports. Well, how often, when, in what format? Spoken, just casual hallway conversations? Are they going to want a deep, detailed account of the testing that I've done, as would happen in a medical device context, for instance, or in a regulated context of some other kind? All these things are things that determine the context. Now, the difference between context-driven testing and context-aware testing is that in context-driven testing, we aspire to engage with the context first. Your context drives your choices, and both your context and your choices evolve over time. That means no test cases and no formalized, proceduralized scripting of testing, unless it's really, really important to do it that way. And, I could say that I think there are actually really few contexts where it is important to do it that way, but that's another matter. But at least when I've got that idea in my head, I can talk to my client about it and say, let's make choices on how we're going to organize and structure the testing based on what we're up against, and refine that as we go. Other prescriptive approaches to testing say, no, you always have to do this. Every test case has an expected, predicted, desired result. Well, that's a silly way to think about testing to me. Because you can absolutely test with open expectations. And I can prove it, which is I can give you anything. What do you got? You got microphones in your hand, right?
Yes.
We did a test of those microphones. Okay. Did somebody say you have to have an expected result before that when we tested the microphones?
Today, yes.
Did they?
Yes.
What was the expected result?
You should hear our voice.
I did.
True.
And it was too loud. Remember?
Yes.
Remember I said it was too loud? Okay. So the expected result there is I should hear your voice. Okay. All right. I can hear your voice. Now, is there a problem? And of course, for me, certainly there was a problem, because the volume was too high. So if we limit ourselves, it seems to me that if we limit ourselves to the kind of test where we say every test has to have an expected predicted result, then we limit our testing to obtaining that expected predicted result and then saying, okay, we're done. And when we do that, we miss important problems. I can guarantee it. Well, I can play this little exercise with you. Victor.
Yes.
Are you ready? I'm going to ask you to tell me about your...
Come on.
Good answer.
Do it.
Do it.
All right, here we go. I've got a calculator in my mind that I'm going to test. I'm going to give you the calculator. I'm going to ask you to test it. And I'm going to ask you to say 2 and then plus and then 2 and then equals. Now, given that, what do you expect?
2 and then plus and then
equal. 2 and then equals. Yeah. What do you expect?
2.
2
2
plus
and then plus.
The equal?
2 plus
Yeah.
equal. I expect 2.
No. 2 plus 2 plus 2 equals. What do you expect?
2 plus 2 equal 4.
2 plus 2 plus 2 equal
6.
No.
right? No.
6.
2 twos. 2 twos. Only 2 twos.
Okay.
4.
2.
Then 4.
4. Is that all you expect?
Actually, I think it's not a simple question. I will say it depends upon context.
It may be binary calculator, right? So
Well, that's a
And-
good thing to point out. Now, but that's not enough, right? Because if you want to give that answer, that's great. That's a good answer. But you can't stop there.
Yes,
So
yes,
so the reply, oh, maybe it's a binary calculator.
yes.
That's a good
I
answer.
thought
That's a
about
good
that.
independent, right? Good. Okay. So now what do you expect?
Actually, I don't know because I don't know
It's not
if
a binary.
it's a binary
I'll tell you, it's not a-
calculator or
No, it's not. But what else? What do you expect? So, assuming that it's not a binary calculator, what else do you expect other than 4? Anything?
any ideas?
2 plus 2 equals. Well, it could be 6,
Why? How?
just due to a bug. No,
You expect that?
I may expect the defect in the function that does exactly that. It could produce the string instead of a digit, right? So it could produce everything, right? Yes, the logical expected result is 2, but it may be totally different result. Yes, 4, right?
4.
Well, right. In the sense that what you're talking about there, I think, is you're talking about having open expectations.
That's right.
Open expectations. But the problem I see with most test cases, the way they're laid out, is that they have a closed expectation and they have only one. So we see the answer 4 and we go, great, and everything's all right. And then we put a check mark beside that and we move on to the next thing. But supposing just before we put down the check mark, the 4 disappears.
So we don't
Did our
assume the
test-
negative cases at all, right?
Well, it's not. I don't think of it as a negative case exactly. I think what you're saying when you say that is, I think you're saying we assume that once we've seen a specified, predicted, desired result, then everything's okay. But you're already showing how that's not true.
Yeah.
That's not true. You cannot trust that. So that's an example. That's, by the way, to go back to an earlier question, that's a great example of the way the testing business hasn't changed very much over the last 25 years. We still have this silly idea that once we've seen a result that we deem to be correct, everything's okay. I mean, it's not, we don't say it quite that way, but that's implicit in the way that these things are constructed. So the 4 disappearing is not part of that test case. But if you saw that as a tester, as a human tester, you would immediately say, oh, wait, that's a problem.
Yes.
Right? You'd immediately say that.
But here, for example, we have a problem because you have 30 years of experience in the industry, in the software testing, and it's easier for you to depend the context. So it's easier for you to identify it and identify the risks. And many people in current software testing are like for 5 up to 5 years. So there are a lot of newcomers, and it's very hard for them to define context. So don't you think that using that strategy will lead them to fail? Just because they're
Okay.
not experienced as you, because it's easier for you and not so easy to them.
Well,
It's a very good point, I would say.
if we teach them the wrong way, then they will learn the wrong way. right? Now, when people come to a rapid software testing class, we don't assume any experience in testing, any particular amount of experience in testing. And in fact, one of the most thrilling things for me as a teacher of testing was to teach a bunch of people who had never been testers before, and indeed who had never worked in technology before, most of them at least. There were 16 people, and it was a group in New York City, an organization that trained people who were coming into the workforce and who were trying to escape poverty. Okay, so these were people who, for example, they were mothers returning to the workforce. There were people, I didn't ask about it, but I suspect it might have been true. There were people who might have been recovering from mental illness. There were people who had been artists, but who were unable to make a go of it. And this organization offered free training for them in IT, and then tacked on to that for the ones who wanted to. They gave a 3-week class in software testing. And we did not teach these people to follow scripts. What we taught them to do was we taught them to learn about a product quickly and to confront confusion, to encounter confusion, and to see something and know they're misunderstanding it, and then to try to sort that out. So instead of trying to teach them how to follow a script, we tried to teach them how to learn about a product rapidly. And we gave them some tools for doing that, for analyzing the product, for, remember that list I just gave you: mission, information, developer relations, test team, equipment and tools, schedule, test item, and deliverables. If we get people thinking consciously about those elements of the context, and then in terms of the test item, the product that they're testing, if we think in terms of, okay, what are the product's bits and pieces? What does the product actually do? What does it do it to? What gets changed or transformed or processed or stored or deleted by the product? How does stuff get into and out of the product? What does the product depend on? What is it running on? And what does it need in order to get its stuff happening? How do people actually use the product in real life, in the world, in their environments, in their contexts, in their business world? And how does the product get affected by time, and how does time affect it? And how does how do things happen or change over time in the product? Those 7 things: structure, function, data, interfaces, platform, operations, and time. We taught those students how to look at the product from that perspective, and we taught them about ways to recognize problems, which include, among other things, is this something like you've seen somewhere else where it was a problem in that other place? If it was a problem, in this other thing, if it's a problem that's familiar to you, it's probably a problem here too. Is this product inconsistent with your ability to explain it? Right? Are you confused by it? Are you baffled by what's happening? Can you not understand what's going on? Well, if you can't understand that, and there's a good chance that somebody who's using the product isn't going to understand it either. Is the product inconsistent with the things that it's trying to model in the world? Right? Does the product not represent the business task that somebody's trying to accomplish, or does it not properly model the object that it's supposed to be modeling? If it's a drawing program, or do things suddenly just disappear as if by magic? Well, that doesn't happen in the real world, right? That happens as a result of some action. Is the product consistent with what it's always done, what it's been doing all along? Is the product consistent with its history? If it's not consistent with its history, we have reason to suspect a problem. Is the product embarrassing? Does it make us look stupid, or does it make us look arrogant, or does it make us look inconsiderate or thoughtless? If it's like that, then we expect that there's probably a problem here. Is it inconsistent with what people say it should do in specifications or requirements documents, or in sales and marketing material, or in help files, or in user manuals, or in some kind of other description of the product? Is it consistent with products like it? If it's inconsistent with products like it, that may be a feature, because we want our product to be different, or it may be a bug. It's so unfamiliar or so inconsistent with other products that it's not right. If it's inconsistent with the result of an algorithm that say, if we put this in here, if we put in 2 and then plus and then 2, and it comes back with 79.7, there's probably a problem here. So we've got that for more sophisticated calculations, we might use Excel to try to figure out what should come out of our calculator. Is a product inconsistent with what people would reasonably want? And not just ordinary, everyday sort of garden variety people, but people with disabilities. Is it consistent with people who are from different cultures or ethnicities or genders than we as individual testers might be? We've got to think about that. We've got to think about other people and people that the team has consistently forgot about. Is a product consistent with itself? That is to say, does it do the same thing over here as over here? Or if it's inconsistent, that could be a pointer to a problem. Is the product consistent with what the designers implicitly or explicitly wanted from it? Right? If the designer said the product is for this, does it do that? And then finally, is the product consistent or inconsistent with standards, laws, regulations, protocols, RFCs, that kind of stuff? Is it consistent with other people say that a product like this should be, or other people that a product like this should do, or a way that the product should do it? All right, you take all those things and you train people in that. Those people who have 5 years experience, that you're saying, oh, well, they don't have very much experience, 5 years. The problem is they haven't been taught that stuff. They haven't been taught of ways of recognizing problems on their own, using their own personal skills, their own experience, their own judgment, their own wisdom. If we teach people to do that, and if we give them a framework for learning that stuff quickly, here's the result you get. And I swear to God, this is true. The other thing that we focused on, by the way, is bug reports for these trainees, these people who are on this 3-week testing program. We focused on them telling us in their bug reports what the problem was as they perceived it, an example of how to see that problem in front of our eyes. So a repro steps, essentially, but they didn't have to be steps necessarily. They could just say, hey, when I do this, this happens. Or on this screen, this seems to be out of alignment. You don't need steps for that, right? You don't need to be too formal about that most of the time, especially if you're in close collaboration with the developers. So problem, example, and the third thing was oracle. A way that they recognize the problem as a problem, which goes back to the list that I told you about. Familiar problems, explainability, world, history, image, claims, comparable products, user desires, product purpose, standards, and statutes. At the end of 8 days of this instruction, 5 days of giving them experience in interacting with the problem and confronting confusion, and then working past the confusion by working with the product and asking questions and interacting with each other and challenging each other and explaining things to each other. Oh, no, I see what it is. I figured it out. And the other person says, aha, oh, I see. I get it too. 8 days of doing that, and we had a little competition. There were 16 people in the group, as I said, and so we got them to focus their attention on testing Microsoft Word's insert page number feature. Okay? There's a feature in Microsoft Word that places a page number somewhere on the screen, and we got them to investigate that and report on problems that they found in that to us. I also participated in this exercise. So there were 9 entrants, and all of those 16 people, plus Paul Holland, who was teaching the class with me, and I judged the bug reports. And the winning bug report, well, let's put it this way. I came in second. Right? The best bug report was from somebody with 8 days of training and testing. That was the best bug report. So when you say 5 years, I think what's happened is not that they have 5 years of experience, but they have 1 month of experience 60 times over and over and over again. And that a great way to make sure that people are slow, that they don't learn very much, is to get them to do something that somebody else told them to do just so. Just make them do it just that way. That's the best way to slow down their learning and to stop it. That's what I think.
Michael, I just one question came up in the chat that catch my eye. There was regarding the interviewing the software tester. So I'd like to raise this question right now. I'm probably sure you've conducted many interviews in many companies, etc. But what's your approach regarding the interview? What are the questions you usually ask, or what approaches do you use to reveal the real knowledge of the person sits in front of you, or how to understand what is kind of person is right here you're interviewing to?
All right. Well, let me go ahead, Victor.
Can I add a little bit to the Anton's question? I would say, from my point of view, the question could be a little bit more generic. How you define that the mindset of the people you are interviewing fits your expectations?
Or the job position, right?
I think it's only about the mindset. You tell a lot of things, really, and I think the Anton's question is about how you define the mindset and define how this mindset fits your expectation about the people you would like to hire.
Okay, so the first thing is we got to be clear on expectation. Okay, so when somebody says, we'll go back to the 2 + 2 exercise.
No.
No.
It's too complex. It's too complex for me.
1 + 1?
Wait a minute. That must be the simplest test you could possibly do, right?
Yes.
It's well, here's the problem with expectations. Expectations can mean at least 5 things, right? When we talk about expectation, and the example that I tend to use is this. When my wife came home with one of these, yeah, you've seen one of these? You've seen something that looks like that? Yeah. I know what that is. That's an Ipod Touch. I didn't expect it to be a phone, but when I found out it was a phone, I liked it. And I expected it to work like normal phones, but wait, where are all the buttons? Oh, you don't need buttons. You don't need buttons on the phone, because if you have some sophisticated software, look, you can have a keypad right there in the phone, and you can use all that space for a display. You don't have to use half the phone for the buttons at the bottom. I didn't expect that, but I liked it. So expectation means what we anticipate. But it can also mean what we desire, what we want, right? To say, well, I expect my operating system to be easy to use and non-interruptive and help me with my workflow. And then we get Windows Vista. Now, I expected Vista to suck because I'd heard about it. It sucked. Completely met my expectations. But there's a big difference between what I anticipate and what I desire sometimes. But then there's another thing which comes up when you're interviewing somebody, which is not just what you want, but what you absolutely must have in a tester, right? Some people have different ones, of course, but that's what they require. It's not just I'd like it, it's I must have it. So expectation can be about requirement, not just desire and not just anticipation. Now, your requirement might be written down, in which case it's specified. But somebody could write something down and get the requirement wrong, right? So that it's not what you wanted. Yeah.
Yes,
well, you're used to that, right? So, expected could mean what's specified, even though nobody wanted it, nobody actually required it, and it wasn't what they anticipated either. So there's a fourth meaning for expected, and then there's at least one more, which is tolerable, acceptable, right? And that came up when I said to my friend Paul Holland, or I told him these different meanings of expectation, and he told me a story where he went into a client with a test result, and he said to the client, well, this isn't in the requirements document, and I don't know if it's required or not, we're not sure if it's what you want. And it surprised us when we saw it. Is this all right with you? And the guy looks at the report and he says, well, just mark it as expected, which means acceptable. So expectation could encompass any one of those things, and any one of them could disagree with some of the others. So in an interview, I'm not so concerned about expectations because it means so many different things. But for a tester to actually get to the answer to the question, what I'm going to do is I'm going to give the tester something to test, or I'm going to give them a thought experiment and say, how would you test this? What factors would you consider as part of it? What conditions would you be interested in? I want the tester to be able to bend their brain around a testing exercise that they've never encountered before. Might give them something that is particularly challenging to test. And there's an example of this up on my website where James and I have a conversation. Imagine a clock in a sealed glass jar. Okay, you can't manipulate the clock. You can't put your hands on it. You can't change it. Can you test it? So I'll watch the tester work his or her way through that thought experiment. Or I will give them something to test, and I will ask them to report on it. So the various things that will go into my evaluation of this. How are they modeling the test space? How are they thinking about how to cover the product with testing? What factors are they considering? And I'm especially impressed when they've considered a factor that I haven't considered, because that means if they're going to be working with me, they're going to have ideas that I didn't have. And that's really, really important. I'm going to look at how well they frame their explanations of what they're doing. Now, that's all of these things are heuristic in the sense that all of them could fail to reveal a problem with the tester that I'm interviewing, or they could fail to help me notice something that's really good about the tester that I'm interviewing. But what I'm looking for is I'm looking for ways in which they would think about covering the product with testing. I'm looking for ways in which they would consider how they would recognize or not recognize a problem. I'm looking for a certain sense of the word that comes to mind is confidence in what they're doing, almost arrogance, but also I'm looking for a certain kind of humility as well, the recognition that there are some bugs that they're going to get past them. I'm looking for, when I'm interviewing a tester to put onto a team, I'd be looking for somebody who fills the space that the team is currently lacking at the moment. So, for instance, if there's nobody on the team who's really handy with tools, I'm looking for somebody who's probably going to be better than everybody else that we've got at creating and producing tools. If we've already got a lot of programmers on the development team or in the test team, then I'm going to be more focused on somebody who has a certain kind of domain knowledge that the rest of us don't have, right? The experience in the business or in the problem that the software is trying to solve. If we've got those bases covered, maybe I'm looking for somebody who's just radically different in temperament from the rest of us, somebody who just thinks a different way. So all of these things weigh into my evaluation of the tester as I'm interviewing it. And I'm always surprised, by the way, when testers ask this question. We know how to test products.
Why are you surprised?
Oh, I'm surprised. I'm surprised because an interview is essentially testing a person for that person's fit on a team, isn't it? Well,
Exactly.
if we know how to test, If we know how to test software, we should know how to evaluate people. If we know how to evaluate software, we should know how to evaluate people. Now, I don't want to be too extreme on this because people obviously aren't software. But we know, if we're good testers, we know that what we're looking for is not whether something is perfect, but whether it fits. Right?
Okay, so, so I just would like to add here just a little question so what skill you usually think is most unique that the tester specialist can possess? I mean, what is the most valuable skill you appreciate personally, and which skill do you usually prefer that your colleagues, your team members have?
Well, to be a really good tester, it seems to me, requires a really healthy dose, not an overdose, but a healthy dose of the critic mentality. The art is somebody who is focused on finding problems in a product and complaining about them in a productive way, right? Somebody who has a desire to identify problems so that the people who are working on the product can be aware of those problems and can fix them, and can do so reasonably gracefully and quite clearly. And if they don't have the skills to do that as clearly as they might, we can work on that. I can train people to be more specific in the way that they're recognizing something as a problem. Or I can get other people on the team to help them with that if it's a particular struggle for them. Not everybody has to be good at everything. But it seems to me that you're not going to be a successful tester unless you are a successful critic. And when I say critic, I mean in the same kind of way that we think about a film critic. A really good film critic does not say, this is a terrible movie or this is a great movie. A really good film critic says, here are some things about this movie that should be interesting to certain people who want to see it. I remember one time reading a review of the movie "Oh Brother, Where Art Thou?" American movie, but by the Coen brothers. And what was interesting about the review to me was how much the reviewer talked about color. The way the whole film had this color associated with dry, dusty, poor places in the American South, and how just the color of the film, and it turns out, by the way, that the directors of the film had developed a whole new color process for this film. What the critic was doing for me was shining light on something interesting about the movie, something that would help me decide, is this a movie I want to see or a movie I don't want to see? So the good critic will give you an overview, a comprehensive overview of the movie. The good critic will notice how music has an influence over the movie. A good critic will notice that if there's no music in it, that's a factor to consider. A good critic will be a student of the history of film and will be able to place the film in its context. A good critic will know the director's work and the actor's work, and will talk about whether this fits with their usual stuff, and if it doesn't, whether it represents a breakthrough in their development or whether it appears to be some kind of misstep, something where they don't seem to know what they're doing. So a good critic will help me to recognize whether this is a movie I want to see. And that, it seems to me, is the essence of what a good software tester does. A good software tester doesn't say this product is good or bad. That's for the people who are building it to decide. What the tester says is, this is how people might have trouble with it. This is how people might be okay with it. This is how these people might have some trouble with it. This is how these people might be okay with it.
Well,
Sorry.
It's a great example with cinema movie critics. But there are a lot of examples of movies when critics liked the movie and the viewers didn't like, and vice versa, when critics disliked some movie and then viewers really liked it, and it had a great great reviews from the ordinary viewers, not the critics. So when you are telling that tester should be like cinema critic, don't you think that tester also make such mistake and consider something as bad when ordinary users will like it, and consider something as good and ordinary users will dislike it?
Of course. I mean, a good critic tries to focus on the audience, right? Right. What the critic's perception of the audience will find interesting or not interesting, or will like or dislike. But you know, here's how I'm old. In that time that I was telling you about, 1994, January or February. I'm not sure exactly what day it was, but somebody showed me this thing that they had running on their computer. Well, it actually wasn't running on their computer exactly, because part of it was running on their computer. The display and the input stuff was running on their computer, but the actual program was running on a computer over there. And I said, "What's that?" And they said, "Well, you know, it's this is a web browser. It's called." It basically allows you to have a program running on that machine over there, but then it displays on this machine over here and gets input from this machine over here, mouse clicks and keystrokes and stuff. And my reaction to that was, big deal. Well, okay, yeah, but what's exciting about that? Who cares? All right, there's something running over there and there's something running over here. Well, this was a web browser, right? So that's why I'm not a builder, right? That's why I'm not a builder, because people were building this stuff and saying, "Oh, this is going to be amazing. This is going to be super powerful." I remember some guy in just a couple of years later who proposed this cool idea that he had. You know what? The whole user interface for the operating system should be a web browser. And I said, "Oh, that's pretty stupid." Well, of course, that's the way most people engage with the web now, because to them, the computer is not this device that can do all these amazing things on it. To them, what they're getting is the experience of Facebook, or the experience of Twitter, or the experience of email, right? And whether it's running on a browser or not is not important to them. They're not interested in the process. What they're interested in is in what they're getting out of it. David Platt, a software developer, put it really beautifully. He wrote a book called Why Software Sucks. And he says it's because the people who are building the software often don't realize that most people aren't interested in the building part. In the same way that most people aren't interested in the process of driving. And he pointed out that developers in Silicon Valley tend to like cars, disproportionately at least, tend to like cars with manual transmissions on them, because they like the sense of control. Now to Europeans, of course, this sounds crazy. To people in, outside of North America, what, a car with automatic transmission? Oh, I guess that's all right. But normal cars just have a stick shift. But in America, only about, I think it's way down now. It's like at 5 or 6% of all cars sold have a manual transmission. The rest of them all have automatic transmission. And Platt says, why is that? It's because most people don't want to drive somewhere. They want to be somewhere. And they're not interested in the process of driving, and they're not that interested in engaging with the car. They just want to be transported someplace, right? Which is interesting, because the very same people who would never, ever give up their manual transmission, those are the ones who are building self-driving cars. Interesting.
True.
Michael, you are talking a lot about your classes, about learning. I would like to ask you a tricky question. Are you uh, issuing a certificate for the people passing your classes. But before you answer, we are going to run a poll and ask our audience about the certification. What actually people think about the certification?
Oh, it's only about ISTQB certification.
Is it?
It's the most
Aren't there
popular
other kinds?
ISTQ.
Well, I don't think so. I think university degrees are more popular certifications than ISTQB is, aren't they?
And while we're watching this pool, Michael, could you pick a couple of questions that you like most in the chat so people can get responses?
Okay, just a moment.
Because I've seen there lots of really good questions.
Okay.
Yeah, that people might
Yes,
get a
yes.
response. Yeah.
And right after
Okay.
this discussable questions, we are going to move to the questions from the chat.
All right. So, well, I think you are talking, Anton. Aren't you talking about questions from the chat right now?
Yeah. You could pick a couple of them so we can discuss them right after this poll. And
Sure.
insofar, honestly, I would predict that the first option would get the most responses, just
Okay.
because I don't know.
I think doesn't have value will be the first option.
I know you can see that.
Actually, I see. Can you show?
Good.
Can you
Limited value now is the first
can
option.
you show us the pool on the big screen?
Yeah, limited value is number one. Oh, see?
And also, please show
Questionable
this
is
pool to the
number two.
Michael.
It gets changing. It's completely
Has
useless.
limited-
24%. Wow. 23.
Well, it's always it's interesting to me. Let's let me just put this out there, and we can put this subject away. But you know, dudes, this is a test result. Okay,
Yeah, true.
this is a test result. So you know, if we're testers, let's take these test results seriously. Now,
Yeah.
if we want people to take us as testers seriously, and let's take testing seriously. One of the reasons the ISTQB certification, it seems to me, is silly. Imagine if you were interviewing a tester. Just imagine if you were interviewing a tester, and you gave that tester a list of 40 questions to answer, and that tester passed, got the right answer 62.5% of the time. 26 out of 40 correct. Okay, so would you hire that tester? Well, that's one thing. But let me change the idea a little bit and think of testing a program. If you had a list of 40 questions for a program, and that program got 26 out of 40 of those questions right, and by the way, based on how the program answered the first question, you didn't change the second question, right? There was no option to change the second question. It was just a simple set of 40 questions that you ask of a program. Now let's take that program and assume that that program is built into a medical device. Would you use that medical device on yourself?
No, thank
Of course
you.
not. Of course not. But let's put it in different way. Like, for example, certification just means that you spend some effort, some time, some, you possess some of base knowledge that you should have. So basically, in my opinion, the certified specialist is like a little bit higher just because he knows the classical approaches. He's not inventing the wheel when he needs some solution, right? You disagree?
No.
Okay.
I disagree. Because you know why? They're not asked to use those approaches in the exam. They're not asked to use them. Nobody tests anything in those exams. If you had somebody sitting down and testing something in those exams, I'd have a different take on it. But we don't. In the province of Ontario, where I live, an aspiring young driver, somebody who wants to get a driver's license, answers 20 questions. And they've got to get a certain number of those questions right. I forget that they're only allowed to get one or two of them wrong. If they get the question wrong, they don't get to sit behind a wheel. But if they do get it right, what they get is to sit beside somebody who is a trained driver, and that trained driver supervises them for a year, or various trained drivers. They're not allowed to drive on their own. They're not allowed to drive without supervision. But the claim from the ISTQB is that the ISTQB certifies that this person is qualified to be a tester. And I just don't think that it's a valid test. I don't think it's a test that in any way asks them to perform testing. And testing is not about getting the right answers. It's not about showing that the product gets the right answers. A test is a performance. A test is a demonstration of learning on the part of the tester, right? Or at least an enactment of testing, not a demonstration, but an enactment of learning something about the product. Well, the 40-question multiple choice thing is a lousy way to do that. Imagine if we tested products that way.
Okay, let's put S2QB away. Do you know any other certification maybe that doesn't have such cons? So not
University-
S2QB, maybe something else.
A university
Maybe
degree.
Michael Bolton certification, no?
But the certification is about respect, right? Certification is about somebody, some person or persons or some group saying, we are willing to speak for this person. We are willing to attest to the idea that this person is an okay person, a cool person. So here's how I certify myself. I certify myself by my community. Right? I look for respect from people that I trust and who trust me. Now, for instance, I've got maybe the most wonderful certification I can imagine from Jerry Weinberg. Jerry wrote this book. See, this is a great book, I think. Perfect Software and Other Illusions About Testing. Okay? Now, I have a signed copy of it. Remember, the title is Perfect Software and Other Illusions About Testing. And here's Jerry's signature in there. It says, to Michael, the almost perfect tester.
Oh, that's
that
nice.
certification means more to me than it's perfect. It's a wonderful evaluation, and I feel very proud of that. That's a certification that I can believe in. James and I regularly certify each other. And here's the thing. If you don't respect me and you don't respect James, then our certification is not going to work for you, right? The way we certify each other in this community way. I certify Elizabeth Hendrickson. Elizabeth and I don't see eye to eye on everything, but she's a phenomenal tester. I certify Fiona Charles. Fiona Charles taught me a lot about testing, and I like to believe that I've taught her something about it too. And we've certainly learned from our experiences with each other, and that's fantastic. So I think, I know that Fiona has certified me because she put me up for a job in 2004. And again in 2005, she sponsored me into that. So that's the kind of certification that I can believe in. But here's the thing that's really important about those certifications, the ones that I've mentioned. First of all, they're not just a piece of paper. They're based on personal reputation and personal credibility of people that we trust. One of the problems that I have with the ISTQB is, quite frankly, I don't trust the people who develop the glossary and the curriculum and the syllabus. I don't agree with them. Now, other people might. That's okay, I guess. But I it doesn't represent testing the way I think testing should be represented.
Okay.
There's a question here which says, from Anonymous. I love this. I love Anonymous. You know, Anonymous, you could actually say who you are. It says, please stop asking Michael cringe and irrelevant questions. Focus on the software industry. Okay, Anonymous, give us a damn question then. Right? Just don't, you know, that is a test, right? It's a test result. Focus on the software industry. Okay. That's fine, but give us, and while you're at it, Anonymous, first of all, say who you are, because it's good to establish your reputation. I want to know who Anonymous is. The reason I want to know who Anonymous is not so I can get angry at them. In fact, I kind of respect them for bringing that up. What's your question, though, Anonymous? I want to know what that is. So you were saying that we would go to questions from the pool.
Yes.
Here's one from Rajesh.
Yes. Let me read the questions aloud. Here is the first question. Risk analysis is the key to testing. What would you be advised to testers to enhance risk analysis skills?
Well, one thing is study risk. Study what it's all about. Read about problems that people have experienced in engineering and recognize that risk, fundamentally, if we want to encapsulate risk, a really great way to think about risk is in terms of a 4-part story. Some victim, that is a person, will suffer, that is, they'll encounter or experience a problem, due to a vulnerability, that is a weakness or a bug or a missing feature somewhere in the system, that is triggered by some threat. That is some condition or some set of conditions that would cause a vulnerability to cause the victim to experience that problem. Okay? 4-part risk story. And forget about this probability times impact thing. Oh my God, what a silly way of thinking about risk. It's people tout it all the time, but really think about it. What's the probability of something bad happening to somebody? Well, we don't really know, do we? I mean, it could be a certainty, I suppose, but other than that, it's a guess. If it's not a certainty, it's a guess. And what is the impact that it will have on them? Well, if we don't know what the problem is going to be, we don't know what that is either. So that's another guess. So probability times impact, that's guess times guess. So the output is guesses squared, right? So if you know, I know in the Eastern Bloc, people are really, really good with mathematics, right? The mathematics teaching there that's long known to be excellent. So there's your units, guesses squared. What if it is a problem that kills a few people every once in a while? Right? Well, impact isn't captured by a single number there. It's captured by a story. It's captured by a story. So the alternative to calculation when we're thinking about risk, it seems to me, is story construction. What could affect people and how might they be affected? Because when we're negotiating ideas about risk, what we're really negotiating, it seems to me, is feelings about bad things that could happen, feelings of dread. Right? So
Okay.
to get good at the skills of risk analysis, look at the history of problems that have happened. If there's been a problem in this domain, could it happen here too? Think about how people could be affected by things, not just directly, but indirectly as well. Think about the knock-on effects of a particular problem in something. All right, so it's just a little miscalculation. Every now and again, we get the wrong phone number. Oh, if we get the wrong phone number, what happens when somebody's trying to dial emergency services? You know, extrapolate and build on stories. Learn the skills of storytelling and story construction. And then look at how risk analysts, real people who study real risk, look at how they think about this. And they don't think about it, for software especially, they don't think about it in quantitative terms. They think about qualitative issues associated with risk.
Okay. The next question is following. There is such opinion that AI and AI-generated tests are going to replace QA engineers in IT companies. What do you think about?
Well, it's a stupid idea. Come on, just cut
AI
it
can
out.
think critically, right?
Right? I mean, think for just one moment. If that were true, why aren't we saying there's such an opinion that AI and AI generated programs are going to replace the programmers in IT companies? Because if you want artificial intelligence to test your software, if you think you're going to do that, if you're going to replace people, how does the AI understand the programmer's intention? How does the AI understand the designer's intention when the programmers and the designers might not be entirely clear on their intentions with each other? How does AI, which is not a social agent, evaluate all the social considerations involved with testing a piece of software? So, I'm not trying to attack the questioner here. I'm trying to attack this
idea.
stupid
Concept, yeah.
This
Oh,
is
yeah,
the-
the stupid idea that's coming from the AI bros, and they're almost universally bros, right? They're almost universally male. What's really interesting is if you want to get good reading on a critique of AI and the silly ideas around AI right now, the women, by and large, tend to be much better at it than the men. Tend to be. Not entirely. There's Meredith Broussard is somebody I'd look at. She wrote a great book called Artificial Unintelligence. Virginia Eubanks wrote a book called Automating Inequality. Those are things that we should worry about. Then there's a couple of other books, one by Harry Collins called Artificial Intelligence, and another one by Ernest Davis and Gary Marcus called Rebooting AI. Don't look at the marketing hype for AI is just marketing hype, for heaven's sakes. This is software. It's impressive in certain things. It can do, it can help us recognize patterns, but it can't do what people do. Come on, shut up.
Okay. The next question.
Mike, maybe you select the question you like to answer. Probably the question you like. Just so you can pick.
Well, we got
any of there.
We got the one from Brijesh. What's your message to those who believe that automation can replace testing? Automation, it can't replace anything that is not grounded in human capability. Remember what I said earlier about what tools do. Tools do not replace us. Tools extend, enhance, accelerate, intensify, enable things that we do. We can't be replaced as humans. Or put it this way, if we can be replaced by machinery, it is a task that we could do, except machinery can do it faster or stronger, more powerfully in certain respects. For example, I can hear outside my window, I can hear a digger, right? One of those loaders. Yeah. Well, those things can enable what humans can do in ways that it would take an army of humans to do in that amount of time. But now all of a sudden we need a skilled person to operate that digger, right? Let me put you in front of one of those diggers and you wouldn't know the first thing about what to do with it and how to do it properly. You'd need training and you'd need skill. Well, that enables us to do things that we could not do at the same kind of scale before, but we still need somebody operating that machine. And we still need somebody asking the question, wait, why are we digging this hole in the first place? And we also need somebody to say, if we dig right here, isn't there a chance we're going to hit pipes or electrical wires? Right?
Yes, but now we don't need 10 people, for example, to dig. We need 1 people and 1 machine.
One person, one
One manager, okay. 1 manager, 1 person, 1 machine. And before that, we needed 10, 20, I don't know, more people.
But we needed, when it comes to, that works fine when it comes to labor, when it comes to work that involves lifting heavy objects. But testing is not about lifting heavy objects. Testing is about brain work. It's about social work. It's about intellectual work. Now,
machines are
machinery doesn't do intellectual work. They enable it. They help it.
so machines are
They enable
replacing
it.
the routine, right? So
You know what
machines are
machines are
replacing the
replacing?
routine, right?
Machines. Do you know what machines are doing really, really fast? Data entry. Looking stuff up and comparing this result to that result. But that's not the interesting part of testing. What the interesting part of testing is the part that goes on in your mind. The risk analysis part. Machines don't do risk analysis. They enable it and they help us to do it sometimes by showing us tables or showing us charts or showing us calculations or enabling us to run simulations. That's the thing that machines are really good at. We can set machines up to run simulations of reality and do things over and over again. That's why pilots, for example, airline pilots, now can become licensed and certified with only 700 hours of in-flight training. 700 hours of flight in an actual airplane. It used to be 2,000. But how can we do this? Is flying more dangerous? No, of course not. Safer than ever. Why? Because the simulators are so good. We can put a pilot, somebody who wants to be a pilot, we can put them in the simulator and get them to practice in really, really challenging circumstances over and over and over again and give them practice and make the situations even more challenging as time goes by without putting them in danger, without endangering the plane or the people on the ground that the plane might land on if they screw up. We can do that now with simulation. So machines can help us in that way. But to say that machinery is going to replace a pilot, go ahead. Get on a plane that is entirely controlled by automation. I've flown 1 million miles and I'm not doing it. I'm not getting on that plane. One that's enabled by automation that has human pilots in control. Sure, I'll do that. And those human pilots, by the way, require more skill than ever because they've got to set up the automation. They've got to set up their interactions with this stuff. Now, I'm not a commercial pilot, but I've been fascinated by aviation ever since I was a kid, and I've been following what actual pilots do and what they say they do and how they do it. And one of my favorites is a guy named Patrick Smith, who says, listen, any civilian, right? You get pilots who are kind of offhanded about that. And this is a mistake they make. This is a mistake that testers make sometimes too. They say, oh, the tools make it so easy. The automation makes it so easy. I just sit there and tend the automation. What Patrick Smith, a commercial pilot, says is a civilian, a non-pilot, would have a really, really serious set of problems figuring out how to use the radio. Just the radio on the plane. He says it takes more skill to set up for an an automated landing, than it does to actually land the plane on your own. And it takes more skill to monitor it and to take control when something goes wrong. So it's something a lot of people don't know. The planes can land themselves, they say. Yeah, and they actually do that about 2% of the time because it's such a pain in the ass to set the machine up for an auto land. It's easier to take it in yourself.
Thanks.
That's for sure.
Could we move to the next question?
Yep.
From Andriy. I have 4 years experience in testing. I just started doing automation. I'm a technical person. What should I focus on in the future as a tester for my career?
I'd have to have a chat with you, Andre, to figure that out because I don't know anything else about you. If you just started doing automation, let me change that, okay? Let me make one little change to that, which is I just started learning how to program. I just started learning how to use tools. And one of the things I would say to you, Andre, is depending on where you're at, but I'm going to go on the balance of probability, you're probably using tools right now, and you can correct me if I'm wrong, to do data entry in a way that somebody says is simulating the user. Well, I don't think it's simulating the user at all, because what it's leaving out of what the user is doing is it's almost certainly leaving out the user's intentions. What it's simulating is the user's keystrokes and mouse clicks. But it's not including the user's motivation, the user's desire, the user's confusion when the user goes through a long sequence of things and out pops a result at the far end. So what I would focus on, Andre, if you're involved in that flavor of automation, I don't like the word automation at all, really. I much prefer programming, because that's what it is, right? It's programming. And it's the automation of really what is fundamentally, I think, pretty trivial tasks. Automation of keystrokes and automation of looking up values in a table someplace and comparing this result to that result. What I would focus on, Andre, is now that you've got some programming skills, what I would like you to do is to think in terms of, what am I doing that a tool could help me to do? How could I visualize the output of scads and scads of outputs from a product? How could I use tools to help me see things? How could I use tools to help me probe things? How could I use tools to help me set stuff up so that sort of tedious keystroke-oriented kind of stuff where the intention is already built in? How can I use tools to help me do that? How can I help me use tools to spin up environments? One of the things I need to do on my website is every 90 days, I need to renew a certificate. And the process I'm going through to do that is just stupid because it's repetitive and you should be able to do it with a button click. So one of the things I want to do is I want to be able to type a command at my terminal for my website and have it go off and fetch a new copy of the certificate and put it in the proper place and set it up and have it be done with it. And it's just this stupidly irritating, annoying, mechanistic, algorithmic, mechanical thing that I could do with a script. Do that with a script. Use that to set yourself up so that now you can use your human perceptual and intellectual and risk analysis and critical thinking powers to think about how might people have problems with this software. Use tools to help you do that. And don't, this whole business of, let me give you the history of this. Okay. Somebody got the idea that it would be a really good idea sometime a long time ago to say, hey, we've got a product and we're not sure it works. So here's what we're going to do. We have an idea that if we put in a 2 and then a plus and then a 2 and then an equals, that the product should produce a 4. Let us take that procedure and write it down for a human to follow, of course, and the human follows it and goes 2 and then plus and then 2 and then equals and then 4. Let's not worry about telling the human, what we're worried about is we're worried about possible risks associated with this, not just with the calculation, but also with any kind of problem that the user might encounter along with it. They might be confused by something might disappear unexpectedly, something might be upside down, something might appear in binary when we want it to appear in Arabic numbers, that kind of stuff. Find problems in this thing. Instead, what we did was we tried to turn this testing into a mechanical rote process. So we wrote a program for a human tester to follow. Now, what we're doing with so-called test automation, right? The basically automated checking at the GUI level is what we're doing is we're saying, take that stupid thing that we were getting the human user to do and take that thing where we were trying to mechanize a human, trying to treat a human as though the human were a machine, and turn that into a task for a machine to operate. So now we're replicating a human user, replicating a machine. Well, that's just really dumb, I think. And we're spending an enormous amount of time. Never in history have people spent so much money writing programs to find a button on the screen, which any normal human can do with great ease. And if the button is moved or if it changed its name, no problem. The human can adapt, but the software can't. Now we have a maintenance problem on our hands.
Okay, thanks. The next question from the chat. Since testing is context dependent, how to choose the best test strategy? Based on which factors?
Well, we don't know what the best test strategy is, right? We don't know what the best test strategy is. So we can decide on what we've got, whether what we've got is good or good enough. And the way we do that is to have a set of diversified set of ideas, a diversified set of ideas, focused on risk, focused on problems that people might encounter, in which we have multiple ways of apprehending the product. And I told you about some of those before, right? Structure, function, data, interfaces, platform, operations, and time. Where we have a set of quality criteria that whereby people could get value from the product, or in the absence or compromise of those quality criteria, value could be threatened for them. So that's capability, reliability, usability, charisma, security, scalability, compatibility, performance, installability, and then development-related quality criteria like supportability, testability, maintainability, portability, and localizability. And then a variety of tests. Yeah. Then a variety of test techniques like function testing, domain testing, stress testing, flow testing, scenario testing, claims testing, user testing, risk-based testing, and then automated checking. Using all those different approaches, diversifying our test techniques, diversifying our notions of quality, diversifying our angles from which we look at the product, the product elements, diversifying our ideas about what the context factors are. Now that's wrapped up for us in rapid software testing. That's wrapped up in something called the Heuristic test strategy model. And I urge you to Google it or to Bing it or to use whatever search engine you like in order to look that up. And that's our model for it. But here's another part of it. To determine whether it's a reasonable test strategy or not, because we can never tell whether it's best, what we do is we share it. We share it with other people, and we ask other people to say, how is this? What problems can you see in my strategy? What things have I left out? What things am I overemphasizing that maybe I should downplay a bit? What things am I not paying enough attention to that maybe I should accelerate my attention or refocus my attention on? And by doing that collaboratively with other testers, with developers, with our clients, with our stakeholders, that's how we decide whether we've got a reasonable test strategy. Because we can't know that it's best. We can't know that it's best.
Okay.
Something could, I'm going to change it for us.
Okay, thanks. Next question about skills. How would QA skills change or be impacted because of the current situation going on? What is your thoughts?
Which current situation going on?
I think it's about the COVID. Yes.
About the pandemic?
Maybe.
I think testing. Go ahead, Anton. You were going to say?
Yeah, I mean, maybe it's about the quarantine because we're all moving
remotely.
Yeah, working remotely with the lack of communication. But we all know that communication is one of the biggest reasons, for the failures. So yeah, so in this situation, what the skills will be most helpful, I guess, right? So that's what is about the question.
I think yes.
Yeah.
People keep saying, oh, this changes everything, right? There's some people who say, oh, this is going to change everything. And then there are other people who say, yeah, in a couple of years, we'll be back to normal. Well, here's the thing. I don't know what the future is going to hold. I don't know. I really don't know. And it'd be smart, I think, for people to be a little less certain about what the future is going to hold. There's all kinds of people who are going to look in their crystal balls and make predictions about the future and so on and so forth. But here's what I think might be useful. And that is to focus not on anything in particular, although you always do that from time to time, right? One of the things I'm doing right now is I'm trying to resharpen my programming saw a little bit so that I can write useful stuff that will help us in teaching classes online instead of teaching them in person. For instance, for a number of our exercises, James and I have added back ends to what were formerly only front-end programs so that we can see what testers are doing. We can log their results and then talk about those in class. And that turns out to be pretty interesting. So in doing that, there's been a whole bunch of things that I've had to reacquaint myself with, including, for example, setting up server-side stuff and configuring things so that they're active or inactive at appropriate times, and just investigating back end things that I hadn't been paying that much attention to lately. Also, coding stuff, working on front end development. I've learned a ton about CSS lately, exactly enough to help me realize how little I know about it, which is always a useful thing as a tester, right? It's always good to learn about something, to remind yourself how little you know. So what I would suggest is to focus on adaptability. Focus on being able to learn rapidly, to be able to reconfigure yourself quickly, to be able to recognize something important that's there to be learned, and to be comfortable with confusion, and to be comfortable with not knowing stuff and work through that confusion. That's a big, big theme in all of the rapid software testing classes, and especially in rapid software testing explored and rapid software testing applied. We're teaching those things online. We've got classes coming up in July and August, and you could look those up. But a huge theme that James and I have been bringing into this is experiential testing, interacting with the product, getting our hands on it, engaging with it, working with it, playing with it. These things help us to learn the product, and they help us to learn about what we don't know. And refocusing on what we don't know and recognizing, I don't know about it, I'm so confused. And then recognizing it's okay to be confused. Being confused is a trigger that should prompt you to say, okay, I'm confused, but the confusion will go away. The confusion will go away with practice and with experience. And so I'm going to immerse myself in this experience. I'm going to learn about it, ask questions, study it, look stuff up, read stuff on the web, try it, practice it over and over again, stumble, make mistakes, lots of mistakes. I'm going to make lots of mistakes whenever I'm learning something new, and learn to be okay with that. Learn to be okay with that. Yeah, that's the biggest thing, I'd say.
Okay, thanks. As a tester, how useful you found your knowledge of development to be? Do you think testers should learn development, as that could help you test better?
Sure, of course.
Okay.
But I do want to put something on it. You don't have to do anything in particular as a tester, right? If you are absolutely allergic to the idea of programming, then don't do it. Now, you might want to go to an allergist and ask yourself, why am I allergic to this? And maybe it's because, for instance, you tried to do it one time and you just got horribly confused, or you got frustrated by the tools because the tools are often hard to set up. Well, every developer goes through that too. The difference between developers and non-developers is the developers learn to be okay with that stuff. So it's related to the other question. What I would say is, if you feel at all like you might be interested in learning development, try it out. Learning programming, try it out. But be aware. You don't have to be a great programmer, but it often helps a lot to try programming a little bit for 3 reasons. Number 1, it will teach you about problems that programmers run into, right? You'll learn about certain kind of risks that programmers bang into from time to time. Second, it will allow you to produce useful tools for yourself that can help to accelerate and enhance and intensify your own testing. Number 3, it'll teach you to be humble. Programming is a very humbling experience. And I had this disease for a little while where I said, oh, come on, it's easy to do this. Any programmer should be able to do this. And then I said, try it myself. Ooh, not so easy. So it teaches testers to be humble when they try to program a little bit. And that's a pretty good thing.
Okay. Thanks. We have really a lot of questions. I'm not sure we will be able to ask all of them. So...
No, we're down to 21.
Let's pick the last one.
Let's pick the last one.
Or maybe Mike, you can pick the last one.
You can
Yeah.
choose.
Choose the last one.
Yeah.
Good question.
Which of those you like the most?
I really don't know. Which it's like
It's always hard to pick the last one.
yeah.
What day?
There's a thing I'd like to ask testers to stop doing. Which, for God's sakes, would you stop asking what's the best tool for testing? Just cut it out. Nobody goes to an artist and says, "What's the best paintbrush?" It's a stupid question. I'm sorry. I don't mean to say that. It's a naive question. I'm sorry. I mean to say. I get excited about it because I've had to answer it so often. It's not a good question to ask. Please stop doing that. Ask a carpenter, well, what's the best tool for building a house? Well, you need lots of them. And you need them depending on the task you're trying to accomplish. Instead of thinking about what's the best tool, and instead of thinking about what's the best anything, really, think in terms of assessing, not declaring something best, but think in terms of what are its advantages, what are its disadvantages? How does it help me to focus my vision? And when I focus my vision on something, what am I not going to notice? How does it bring something very, very sharp and clear and then blur everything else out? How does it allow us to zoom in on something very, very specific, but allow us to miss the bigger picture? How does this tool allow us to get a broad overview of all kinds of stuff such that it will defocus us from little details? Think in those kinds of terms, and then don't think in terms of what the best is, but think in terms of what might be useful and associated problems with it in a given context. And you'll be much better off that way, it seems to me. So that's and that applies to all kinds of things in testing, not just to tools. Best test technique, best form of documentation. Stop it. we
Best
make
standard.
choices. Yeah, best standard.
Best strategy.
Here's something which I think is terribly important for testers to recognize. And that is the concept of agency, the concept of choice. An agent, somebody who is an agent in the rapid software testing way of thinking about something, is somebody who is responsible for their own choices and for their own decisions. So every time you're tempted to say, but I have to, change that in your mind. Change that in your mind to, I choose to. Because as soon as you take out I have to and replace it with I choose to, now you've got all kinds of motivation for thinking, what might influence my choice? How might my choice be a good choice and how might it be a not so good choice? Why am I choosing this to accomplish this particular goal? What other choices are available to me? Now, there's some people who say, oh, but we have to have test cases because the standards say so. The standards, certainly the FDA standards, do not say that you have to have test cases. Right? The standards, the FDA guidance documentation says at the beginning of it, there's such a thing as the least burdensome approach. The least burdensome approach, the principle of the least burdensome approach says, if you can figure out a better way to uphold the principles of what we're doing, the ideas behind what we're doing, that's different from our guidance documentation, you are free to do so. You are free to do so if it reduces the burden on you and allows you to do better testing. Now, of course, part of that deal is you can choose to do that, and then it now puts another burden on you in some sense, which is you will be compelled to justify to an auditor who has not seen this way of doing it before why it makes sense, why it's the right thing to do in your context in that time. But that's a choice that makes a whole bunch of sense when, if you're in a regulated environment, when you're dealing with medical device software, your goal is to prevent people from dying or being injured or hurt, being hurt by this thing. I want to focus not on, I don't want my documentation, for instance, to swamp my primary task, which is to find problems that might harm people, that might cause loss or damage or bad feelings or economic loss, bad experiences for people somehow or other. Anything that gets in my way of doing that, I want to think very carefully about the value of doing it and the cost that comes with it and the risk that comes with it. And that is principally the risk that while I'm doing that, I'm going to miss an important problem in the product. So just bear in mind that in regulated environments, even in regulated environments, the regulators aren't stupid. The regulators recognize that your principal job is to avoid harm. And if you are so overwhelmed or overburdened by the documentation effort such that it distracts you from the avoiding harm part, then it's time for a conversation with the auditors internally or externally, with the regulators, and to say, here's how this burdensome approach might be damaging our capacity to find problems that matter to people. If you have the agent mentality, if you are responsible for your choices, if instead of saying, I have to, you say, I choose to, and here's why I choose to. Because the thing you say you have to do, that might be a really good choice. But let's do that consciously. Let's do that thoughtfully, not just by rote, not just because somebody's saying we have to, but because we consciously decided to do valuable, important work that helps to reduce harm and risk for people.
Thank you, Michael. I would say just it was really emotional interview, I would say, and
Very
pretty,
inspiring.
yet very inspiring and pretty interesting. I would say, guys, I'm sorry that we have no time to ask all questions you put into the chat. I would say, Michael, you did a really great job. I really enjoyed talking with you. So I hope you guys also.
Yes.
Yeah, I would say personally, you're so emotional when you're talking about testing. You're so inspiring. I feel like you live this. You live with testing. So it's very nice to see such kind of people that are very passionate about testing. Really, it can be seen in their eyes.
Interesting. And thinking.
Yeah, thinking, of
thinking.
course. Yeah. So personally, I was really enjoyed this interview. Thank you very much, Michael.
Thank you.
I appreciate that. Thank you. Could I once again offer two things? One is I am at Michael Bolton on Twitter. I am michael@developsense.com in mail. You can find me on LinkedIn. You can find me anywhere on the web, Michael Bolton, but add testing, otherwise you'll get that singer.
Yes.
Anybody who's got questions, you're more than welcome to ask me in private or public forums. I don't mind. I enjoy it. I appreciate it. And that applies to all kinds of forums that are out there. And those people who have taken their rapid software testing class know that the rapid software testing Slack forum is a place where we can do that too. And we have really good conversations there. And then in our classes, in the rapid software testing classes, one thing we try to share, because we can't quite teach it, one thing we try to share are all the different ways in which we can make testing engaging and enjoyable and focused on finding out important things that matter to people. That's if that's interesting to you, come join the class. If it's interesting to you but too expensive, then at least you can look at my website, developsense.com. And most of the good stuff there is in my blog. You can look at James's website, and he's got a fantastic library of papers and articles and so on. I've got some of my own stuff on my blog too. James's is satisfice.com. There is a community of people who are inspired by doing inspiring testing work, and I've seen some of those names show up in the questions there. Brijesh is an example of somebody who on LinkedIn is passionately engaged in this, testing doesn't have to be, dull and boring and tedious and drab and awful. Testing can be this engaging, exciting, fascinating, multifaceted thing. And so we encourage people to join us, and we encourage people to ask questions and get the dialogue going.
Yeah, I think after this evening, number of people that will join your community will increase. And thank you for inspiration and a lot of things that we now have to think about.
Thank you very much.
Agree that. Yeah.
Thank you, Michael. Till the next time. It was Michael Bolton, one of the mostly wanted and known tester in the world. See you, Michael.
See
it
you.
was
Thank you very
really a
much.
pleasure.
Yeah.
Bye.
Thank you very much. Bye-bye.